In this question, we have a student planning to conduct an experiment in which the momentum of a two-object system can be determined immediately before and after a collision. The student slides the block, x, at an unknown constant speed. So there's some unknown constant speed, v, beforehand, an identical block, y. So mass of x equals mass of y. They're identical. No friction. Uses the data collected from the experiment to create the data table. Which following statement is true regarding the data? So we look at the data. The first thing we see is that there are 3 trials of the momentum x beforehand. So we obtained 3 different values, and we can see that the mean value would be 6.0. Now, momentum y beforehand, we have these 3 values. And that value would be 0.066 repeating. The momentum of x afterwards, we've got our before on the first 2 columns. We have our afterward. We have -1, and this all adds up to 0. So block x stops. And when we look at y, we get a value of 5.23 repeating. So beforehand, we have a value of 6.066, the initial momentum, and the final momentum afterward is 5.23. Now, there are a couple things that seem odd about this. We are told that block y is at rest. So the momentum of y should be 0. This is bizarre, that's not 0. And it's also bizarre that these two are not equal to each other. We would expect them to be equal to each other, but based on the data, they're not. So there's some anomalies going on here. So let's examine each of the choices. The momentum of the 2-block system is conserved. That doesn't seem to be the case. It seems to be that there's less momentum afterward. And that is the same logic applies to both these first 2 choices, at least in that first clause of the answer. The momentum of the 2-block system is not conserved. Well, that does seem to be more consistent. The level of error associated with the data is too high to make a conclusion regarding the momentum. Now, if we look at the level of uncertainty, we might say this is 6 plus or minus 0.1. And these values here are 0.1 plus or minus 0.1. And this value here is 0 plus or minus 0.1. And this last value would be 5.2 plus or minus 0.1. So when we look at the overlaps here, we have 5.2 plus or minus 0.2. And we have 6.1 plus or minus 0.2. So that means an upper limit of 5.4 all the way down to 5.0. And this one is an upper limit of 6.3 all the way down to 5.9. There isn't overlap in those answers. And since there isn't overlap, the error isn't so large. It's not too high. The error here actually suggests they're different from each other. So this choice is definitely out. And if we go back to looking at these 2 that looked like we were going to exclude, we read the rationale here because the initial momentum is not equal to the final momentum. We don't like that. That's not what we expect. There's anomalies in the data that don't make sense. But given the uncertainty, this would be the valid conclusion, which would suggest, of course, that the laws of physics are not true. But that is what the data shows, and that's why that's the answer. And if we want to look at the second, let's go back and look at the second clause of each of the incorrect answers above, because the initial momentum of the block is experimentally consistent for all trials. Well, all that does is tell us about the size of the plus or minus. That's not a reason unto itself. And the final momentum is consistent. Now, because the data is consistent, doesn't mean anything about whether the momentum is conserved. The momentum, the trials can be consistent and they can still be different. And we might argue that the data is consistent but it's not conserved. So what we say about these two things is the first and the last clause, it's a non sequitur, meaning it doesn't follow. The two aren't connected to each other. And again, that's why that's the correct answer there.